Now let's take a look at this pop grain node a bit closely, and let's in here create a dry sand and wet sand looking effect. And right now if I hit play, and here you can see we are using this default settings, and by the way these default settings are fine. And in here I'm going to just go back at the very first frame, and in here first I'm going to create increase the number of particles, these sand particles. And to adjust this we need to lower down the particle separation. So let's lower down the separation value to 0.05. Let's start with this value, and now we have more sand particles, and let's hit play. And in here, as you can see, right now we are using this grayish looking color lit sphere visualization, and because we have the ground plane and that its color is too gray, so it's a bit harder to see, bit harder to visualize. So what I can do, I can create a pop color node to set this color of the sand particles to maybe a sand looking particles. So in here let's create a pop color node. So let's add this in here, and I'm going to just connect this in between, and maybe let's select all of these nodes. Let me press escape key because I have wrongly selected from these inputs. Let's select all of them, and to arrange them to make these nodes align, let's go into the layout, and in here let's align these nodes vertically. And now we have this alignment. And let's go into the pop color node, and right now we are using this basic color, and in here I'm going to use the ramp, and right now we are using this grayscale ramp, and in here we have some presets. Let's click on it, and from there let's pick the sand preset. And in here right now we are setting the color of our particle based on their normalized age, but I want to pick a random color from this ramp. I want to pick a random color to set the color of these particles. So to make all of these particles pick random color from this ramp, we can use a random function. And in here, if I were to middle mouse button, here you can see we have the number of points, number of particles, and in here we have a ID. So ID is a unique value that has been assigned to each of these particles, and it is a unique for all of these points, and ID will not going to be reused. So it's going to be used once for each of the particles. So which means we can use this ID to create our random color. So in here at the ramp we can create a random function. In here let's add a rand function. Rand is a vex function. So if you type rand, here you can see we have this function. Let's click on it, and inside of the brackets, to generate the random value, it needs the seed. We need to define the seed to create the random value. And for the seed I'm going to use the ID because all of these particles have an ID, and it is unique to each of these particle. So in here I'm going to say add, which means that we want to use the attribute, and now I want to type the attribute name, and that is the ID. And now let's close this small bracket, and now this will create a random value, and its range will be in 0 and 1. It will give an output the 0 and 1 value and assign random value to each of these particles, and which means that based on their random value they will going to be pick their color from this ramp. So some of the particles will get a white color, and here you can see some of them do have white color, and some of them will get this darkish yellow color, and that is a bit more like a sand color. Let's go back, and in here let's hit play. So that is our visualization, and right now here you can see our particles are sliding, and they are sliding quite a lot, and that is because whenever we are working with the grains, whenever you are creating this pop grain node, we need to increase the number of substeps. We need to increase the number of substeps because this pop grain node has to calculate the collision. And if I were to play, and maybe let's enable this real-time playback option as well, And in here you can see we have this collision. All of these particles are colliding with each other, and that's collision is what making these particles looks like sand. That's what giving them volume, because they are colliding. And to actually make this simulation accurate, we need to increase the number of sub-steps. And right now by default, this pop solver, if I enable the parameter, it uses the one sub-steps, and one sub-steps is enough for creating your normal particle simulation. But whenever we are working with grains, we are creating collisions inside of these particles are colliding with themselves. We need to increase the sub-steps. And whenever working with grain, you should always start with the sub-steps value of 10. So let's change the min and max sub-steps to 10. So let's start with that value. And now if I were to hit play, and here you will see our simulation do get slow, but we will get an accurate representation of our simulation. And in here you can see our particles are still sliding, and that is because we have this dry sand, and dry sand particles do the sand particle do slide. And in here let's go into the pop grain node, and in here at the very first we have the friction, and we have the friction with the collider and with the particles themselves, and its range is in 0 and 1. And if I were to lower down the friction value, let's change the friction with collider to 0, and here you will see that our particle will slide quite a lot because we do not have friction. And in here you can see now our particles are sliding too much. So the default value of 1 is fine, and we have the friction with particles and it is set to 1, so that default value is fine also. And down here we have the static threshold, and that is the value that it says that if the particles has a speed of 0.5, make these particles static, do not make these particles move. So if I were to increase this threshold value, and here you will see that more and more particles will come to rest, and here you will see they collide, and because they have an initial kinetic energy, and after that they are becoming to rest. And here you can see we do not have a sliding effect because all of these particles has comes to rest. So the default value of 0.5. And down here we have the scale kinetic, and this scale kinetic is the value that how much of their kinetic energy should be removed from the simulation. And if I were to increase the scale kinetic, and if I were to increase this, which means that I am removing more and more energy from these particles. And right now if I were to hit play, and here you will see that our particles will still come to rest. So both of these parameter has the same effect. It's just that both of these parameter control different values. So it is a scale kinetic is an energy subtraction, how much energy we want to remove from our simulation. As always, the default are fine, make them to 0.1. And down here we have the internal collision, and that is the collision that actually making these particles to collide with themselves. And if I were to zero this out, and it means that all of these pop grain, all of these will have no effect. We are still calculating slow because this has to calculate, but because we do not have collision, our simulation just look the same as if we do not have the pop grain node. And if I were to shake this node off, and if I were to hit play, and here you will see that yes, we do get some bounciness, but here you will see we do not have any collision. And onto the pop grain, as you know, collision is what makes this particle special. So onto the pop grain we have the internal collision, so we need to keep all the way up to 1 because we do want the collision, and that's what's giving them the volume. And in here we have the stiffness, and the lower stiffness value cause particles to bounce more. If I were to lower down the value, and here you will see that our particles will bounce quite a lot, and if I were to hit play, and here you will see that we have quite a big bounce, and this lower stiffness value causes these particles to bounce. And same thing, if you were to increase the stiffness, our particles will bounce less. And if I were to hit play, and now we do not see that much of bounciness, and here as you can see. And same thing, the default is fine, just keep this at its default value. And down here, that is the most interesting setting, and that is the clumping. And this clumping is what create our dry sand and wet sand effect. And in here we have the weight, and which mean that its range is in between 0 and 1. 1 mean that we are going to creating the clumping, and we are going to use this stiffness. And if I were to change this to 1, and right now we have the stiffness, and right now it's in a very low value, but if I were to hit play, and same thing, here you will see that our particles are now sticking together, and they are sticking together as they should be. And if I were to increase the stiffness, which means that I am creating a more wet particles, more wet sand. And if I were to, maybe let's keep increasing this value and let's hit play, and here you will see that all of the particles now try to stick together. And here you will see, here as you can see, the particles are not even breaking their shape, as if we have a mud. So that's, maybe if you want to create a mud simulation, you can just increase the stiffness value. And same thing, let's lower down the stiffness, and we can keep playing around with the stiffness value until we see a wet sand looking effect. Maybe let's lower this value down to 25, and in here as you can see, we have a wet sand looking effect. Maybe let's keep lowering this value down, and let's hit play again, and there you go. And in here, onto this clumping, we have this weight, and this attribute is called the attraction weight, which means we can create this attraction weight attribute beforehand. And if we go into my this SOP level, onto my this grain source, and in here, as you know, right now we are creating these points, these particles, and we are only creating an p scale attribute. If I were to middle mouse button, and here you can see we only have the p scale, and that's what setting the scale of this particle. And in here I can create a attraction weight attribute to say that these are the particles that are wet and these are the particles that are dry. So I can set these beforehand into my this SOP level, geometry level, into the SOP, and when they will be going to be imported in here, this pop grain node will read the attraction weight attribute to set the clumping. So in here, maybe let's create a attraction weight attribute, and I want to create a noise based attraction attribute. I want some of the particles to be wet and some of the particles to be dry to create a interesting sand effect. So in here I'm going to use the noise. So let's add a attribute noise to create our noise based attribute. Let's add this, and as you know, by default this attribute noised up our CD to create a random color. And in here I want to create an attraction weight attribute, and that is a float. Let's change this to float. And in here let's type the attribute name that you want to create, and I want to create attraction weight attribute. And now the attraction weight attribute has been created. And in here, to actually visualize our this attraction weight attribute, we need to just click on this button, and I think the visualizer were on. By clicking on this we can enable or disable. Let's click on it, and here you can see we are visualizing it, and if we click this one more time, that will just disable the visualization. But right now we are not visualizing our this noise based attraction weight, and that is because of the lit sphere visualization. And to actually make our this noise visualize, we need to change our this visualization. Let's go into in our display option, right click, and onto the particles, let's change the visualization to points. And in here you can see we have our visualization. So this visualization actually does not work on the lid sphere. If I were to change this, and here you will see our visualization is gone. So for now, let's change these 2 points, and in here I can play around with the amplitude, and in here I can play around with the element size to create a high frequency or low frequency noise, adjust the amplitude. And in here, make sure that our values in 0 to 1 range, because this PopNet, our attraction weight, its value is in 0 to 1. So we need to make sure that this noise is outputting 0 to 1. And we can actually adjust this by going on to the post process. Let's collapse this menu, and in here I'm going to just enable minimum and maximum, and it will just clamp these values to 0 to 1 range. And now this noise will work fine. And in here, now let me increase this amplitude, and so that we have some bigger patches. And now let's go into the PopNet, and in here let's see, and let's change our visualization back to lid sphere. Right click and let's change this to lid sphere. And now we should see some of the particles are dry and some of the particles will get a wet sand effect. And here you will see, here as you can see, we have the partitioning effect, and I can control my overall this dry and wet sand effect by going on to the attraction weight. And in here, if the PopNet has been visualized, here as you can see we have this weird grid visualization because we are actually importing this ground plane as well. And to fix this, let's go into the PopNet and enable its parameter, and here we have the option to objects, and it's saying that which objects that you want to import. And in here, let's only import the pop object, because we know that this pop object store these particles. So let's go back onto the PopNet. I'm going to just remove this wildcard. It's saying that import all of the objects. Let's remove this. And in here, let's pick our pop object and let's add this. And now here you will see we are only importing these particles, and we are not importing this ground plane geometry, and we have this good visualization. And in here, let's go into the attraction weight. I'm going to increase the values. Let's go into the visualization mode. Let's change this to back 2 points, and onto the range I'm going to change this to 0 centered, so we have a 0 centered values. And now all of these red particles will get a wet sand, and all of these that has a purple color, that will be our dry sand. So let's go into the PopNet, and in here let me change this back our visualization to lid sphere, and let's hit play again. And in here we should clearly see the different partitioning. And here as you can see, let me dive inside, and in here you can clearly see that we have the effect. So we have the clumpiness, we have these wet sand, so wet sand are sticking together, and we have the dry sand and they are sliding too much. And to actually not make them not slide that much, maybe let's go into the pop grain node, and in here I'm going to just remove out some of their kinetic energy. So let's increase the scale kinetic. I'm going to just change this to 0.67, and let's see how this value is looking. And I think that this 0.67 is fine, and we still have some of these particles sliding. Let me go and let's increase the scale kinetic 0.8, and let's hit play again once more, and let's see. Now they are not sliding that much, and I think that value is fine. And remember that right now we are using lot less particles, and here you can see we have these bigger chunks, we have these bigger sphere. That is because our particles amount is not enough, and we will pick more detail when we have more particles. So maybe let's increase the particles, and in here I'm going to change the particle separation to 0.01, and by doing so, and here you can see we are creating lot more particles. And now if I were to hit play and simulate, and it will take longer to simulate, but we will get a much high res version of our simulation. And let me simulate few frame, and I will come back with the result. I had to stop the simulation because it was taking quite a lot of time to simulate, because we are working with lot more particles. And here you can see I have a very few cached frame, because of these sand particles, they are taking quite a lot of system RAM, and I do not have that much RAM. That is why all of these previous frame do not get cached. So maybe let's go back, and I'm going to just increase the particle separation to not create that many particles. And you can create that many particle if you are going to render this, and because after that we are going to create a file cache node. We are going to add a file cache, and we are going to writing out all of our caches. So in that case, this particle separation value is fine, because right now we are just checking out the simulation setting. The value of 0.01 is just too slow, so I'm going to just increase this to 0.03, and let's hit play again. And as you can see, the value of 0.03 is much more manageable, and we still have quite a lot of resolution in our particles. And in here you will see some of them particles will have a wet, and some of them will have a dry sand effect, and here you can clearly see. So that's how you can create the wet sand and dry sand effect.